Okay, 2.2, adding, subtracting, and multiplying polynomials. Okay, so first we're going to look at monomials, and we'll get a little bit more into the definition of polynomial. These are all monomials. If you look here, these are single terms. And the first thing we need to look at is like terms. So what are like terms? Well, here are some examples of like terms. So 2y and negative 7y. 0.5z to the fifth, 4z to the fifth. We have 10x y to the power of 2, and then we just have xy to the power of 2. So those are a couple examples of like terms. Here's some examples of unlike terms. So we've got 2x and then 2y. We've got a 3w, but then we have a 9w to the power of 2. Then we have xy squared, and then we have the x squared, and then just the y. So what is consistent here? What makes the like terms? What makes them unlike terms? Well, let's focus on what makes them like terms. So what you should notice is to be like terms, they have to have the same variable with the same power or exponent. Power and exponent are interchangeable. They're the same, they mean the same thing. So I'm going to go ahead and write that here. So what makes like terms? They have the same variable and exponent. Okay, could barely fit that in there. Sorry for the messy handwriting. So to be like terms, we have the same variable. So if it's a y, it's a y. If it's a z to the fifth, it also has to be a z to the fifth. So if they don't, then we're not going to be able to add those terms or subtract those terms. So that's why we're talking about like terms. The only way you can combine like term, or the only way you can combine terms is if they are like terms. Multiplying and dividing will be a whole different story, and we'll look at that a little bit later. So let's take a little deeper dive on this. So when expressions have like terms, we combine the terms coefficients. The coefficients are the values in front. So right here we have 2y minus 7y, okay? And so right here you're going to basically perform the operation of 2 minus 7, and that's how we get the negative 5y right there. And so I can kind of show you, we haven't quite got into factoring yet, but let me kind of show you a little explanation of this, because you're going to see factoring anyways in a little bit. So you'll notice that they both have in common that y. So what I can do is, this is called factoring. I can factor that y on the outside. Okay, so you can see I have that y on the outside here. And so then that, if I were to distribute that, if I were to multiply that back in, I'd have 2y minus 7y. But I don't want to do that here. What I did was I took that y out, and then I did 2 take away 7, gave me that negative 5 right there. Okay, and now make a little bit more sense once we get into our factoring and all that good stuff. Okay, let's look at our next one here. So I have 1/3 z to the fifth plus z to the fifth. And so that has an understood 1 in front. But what I'll do is I'll put that as a 3/3, right? 1 is the same thing as 3 divided by 3. So then, once again, what you would do is kind of factor that z out. So you'd focus on having 1/3 plus 3/3. And I have the z right there. And then we have common denominators, so 1 plus 3 is 4 over my common denominator of 3, and then I have, oops, forgot my power right there, z to the fifth right there. Okay, and so we're going to practice these in just a moment. So just a little terminology. So we've been dealing with monomials. That's where we have a single term. Binomials, if they're being separated by addition or subtraction, and there's 2 of them. And then trinomial, we're at 3. After 3, we just use the generic term polynomial. But all of these are polynomials, actually. Even the single term ones, we call those polynomials. But a single, double, or triple, we can classify those. Okay, so on this first part it says, in each polynomial, combine the like terms whenever possible. Write the results in descending order of powers. So you typically want to write the highest power first. Okay. On these first couple, it seems like they're all going to boil down to a single term. Or on number 5, we'll have two different terms. We'll have x and y, but the one's not larger than the other. And so this will come into play a little bit later. We won't see it so much on these first 3 examples. Okay, so looking at number 1, I have 8x to the third power take away 3x to the third power. Okay, so it's like saying I have, I know I have x to the power of 3 right here, but it's just saying like I have 8 pairs of shoes. I take away 3 pairs of shoes. I'm left with 5 pairs of shoes. Now my pairs of shoes in this example are my x to the third power. Okay, you want to think about it that way because the common mistake students will make is they'll actually take off the x cubed. They're like, well, yeah, I subtracted the x cubed. It's gone, right? Well, you have a multiple of x cubes. You had 8 x cubes, and you're removing 3 of your x cubes. And so you still have 5, and then don't forget you have 5 what? I have 5 x cubes left behind. Okay, looking at number 3, very similar to number 1, except there's 3 terms here, and you want to just, with addition and subtraction, if you remember order of operations, you want to go from left to right. So if I were to add first, I would get the wrong answer, so you don't want to do that. So we got to start with this part right here. So I have 6x squared, I'm taking away 7x squared. So I have 6, I'm taking off 7. So if you remember what you do here, I mean, this is the same thing. Let me show my work so we don't get confused. Oops. That's the same thing as though if I were to put plus a negative, right? 7x squared. And I got plus 3x squared right there. So you're competing. One's positive, one's negative. So take the difference. So 7, take off 6. That leaves you with 1. But it's going to be a negative 1x squared because the larger number was negative. So you take the sign of the larger number. So remember, there's a little battle going on, right? So the larger number wins. And so you keep their sign right there. And then we have plus 3x squared. And so we've got a battle going again. We have a negative 1x squared. And we're adding 3x squared. So you take the difference again. This time we get a 2. This time it will be positive 2x squared because the larger number was positive. They're the winner. We get to keep their sign, which is positive. So we're going to keep this positive. Okay, my next example, we have 3x minus 2y minus 4x plus 6y. Now, what we can do here is we can use the commutative property, and we've done this in multiplication. Remember, 2 times 3 is the same thing as 3 times 2, right? Okay, the difference here is when you do the commutative property with addition, it's fine. It's not really that big of a deal. But when subtraction is involved, you have to make sure you move the sign with it, okay? So what I'm going to do here is I'm going to put the 3x and the minus 4x next to each other. So it's going to be 3x minus 4x. And then I have the minus 2y and the plus 6y. So I got to move the minus with the 2y back here, and then the plus with the 6y back here. And so I'm just trying to order this a little bit better. And so now I can go ahead and look at each one individually. So I have 3 x's. I'm going to take away 4 x's. Okay? So I have 3. I'm taking away 4, so I'm taking more than I have. So that's going to put me in the negative. So this is going to be negative 1x. And then right here, let's see, I have minus 2y plus 6y. So they're going to battle it out. And the positive number wins by 4. So that'll become a plus 4y right there. And that's your answer. That's our answer right there. Because now I have an x, I have negative 1x plus 4y. I can't do anything about that. Those are not like terms, so I can't try to combine those. Those are going to have to stay separate. Okay, so here we're going to continue what we've been doing, except that we're dealing with some bigger polynomials and more terms that we have to combine. So it says perform the indicated operations, write the resulting polynomials in standard form, and indicate the degree. Okay, and so we'll talk about that. The degree of the polynomial, I guess I didn't mention that on the previous page. It's just the highest power. So the degree of this polynomial is 3. The degree of this polynomial is also 3. So it's just the highest power that you see, the highest exponent. That's all that is. So what's the degree? So if you get that question on a homework assignment, it's just whatever the highest exponent is. That's all that is. Okay, so we're adding these two together, okay? So really the parentheses aren't necessary, so I'm going to go ahead and just rewrite this. So negative 6x cubed plus 5x squared minus 8x plus 9, and then plus 17x cubed plus 2x squared minus 4x minus 13. Okay, I got a lot going on here, okay? So what we want to do is, I'm going to go ahead once again, kind of like I did on the previous page, and I'm going to move things around. But you're going to have to be careful with the signs. And if you're really good at this, you can do a lot of this math in your head, and I encourage you to. But if you're not comfortable with that, I'm going to kind of show you a little bit more detailed approach. So let's see, I've got a negative 6x cubed plus 17x cubed. If you can do that in your head or off to the side on your paper, great. And actually, I don't have a lot of room, so come to think about it, this is probably the way I'm going to do it. But if you're not comfortable with this, you can, kind of like what we did on our previous page, you can rewrite them first and kind of put them next to each other. But this is a very popular approach that I'm doing right here. This is how most instructors would show you how to do it. So let's see, I have a negative 6x cubed plus 17x cubed. So I'm combining. Combine means to add. I'm going to add these together. And they have competing signs. So I'm going to take the difference, and then I'm going to keep the sign of the larger number. The larger number was positive, so that's going to be 11x cubed. So I combined those like terms right there. My next term I'm going to look at are my squares. Here I have 5x squared and I have 2x squared, and they're both positive. They're both on the same team. So I'm going to go ahead and add those together, which is 7. So it'll give me 7x squared. Next will be my x's. So let's see, I've got a minus 8x and a minus 4x. They're both minus, so they're both on the same team. So I'm going to go ahead and add that together, which is 12. But it's going to be a negative or a minus 12x because we're being subtracted. So I add them together, but then keep the minus sign. Okay, if you were multiplying, obviously that would be a different story. Okay, but we're combining, we're adding. And then the last one, let's see, I've got plus 9 and minus 13. Okay. Those are competing against each other because I'm going to add them together. One's positive, one's negative. So take the larger, subtract the smaller, which gives me a 4. Let's see, it's going to be a minus 4 because the larger number was of the negative sign, of the minus sign. And so there we go. There's my polynomial right there. And then if they ask, it is a degree of 3. That was the highest exponent power that was part of my polynomial. That's all they're asking for. They ask you what's the degree of the polynomial. And then you can also see I did go in descending order of powers. 3, 2, 1, and then this one doesn't even have 1, so that would be known as 0, right? It's exponent. Okay. All right. Hopefully that wasn't too bad. Now looking at 11, there's a big difference here because I have a subtraction here. And so what I'm going to have to do here is distribute that. So I'm going to have to multiply all these by basically a minus 1 because I'm subtracting the whole quantity, not just the first term. So you want to make sure that minus gets distributed to all parts of that polynomial that I am subtracting. So let's see, I'm going to have, 17x. So the first one stays the same. Nothing changes with that. And then I'll color code this a little bit. So see, basically all the signs are going to change. So this positive 5x cubed is going to become a minus 5x cubed. This minus 9x squared becomes a plus 9x squared. This minus 8x becomes a plus 8x. And then this plus 11 will become a minus 11. Okay, so then now it's time to do exactly what we did up above, is just combine our like terms. So let's see, I have 17x cubed minus 5x cubed. So I had 17, and I'm combining them. So one's positive, one's negative, so take the difference. And that'll give me a 12, and it'll be a positive because the larger was positive. So 12x cubed. Okay, then we have a minus 5x squared and a plus 9x squared. Once again, we're competing. So take the larger, subtract the smaller, which gives me a 4. Once again, the larger was positive. So once again, we'll put a plus here. So I have positive 4x squared. Okay, then our next one is we have a plus 4x and we have a plus 8x. So they're both positive in this case, so that's not too bad. So I just add them together, and that'll give me a total of 12x. Okay, and then our last one, we need to combine our constants. We have a minus 3 and a minus 11. They're both minus, so they're on the same team. Add them together, which would be a 14, so it'll be a minus 14 because they're both minus. Okay, I've got one more for us, and then that will conclude part 1 of our video. And then there'll be a part 2 where we'll look at multiplication. Okay, so here my polynomials are degree 2. They're all degree 2. Oh, by the way, the previous one was a degree 3. So if they ask that, you just look at the power. Don't think too much about it. All right, so on 13, my degree is 2 on all these, and so I've got they're all trinomials, by the way, also that would be their classification, and so I'm adding and subtracting a polynomial. So you can do this in multiple steps, or you can do it all at once depending on how comfortable you are. Okay, but first things first, we'll go ahead and get rid of our parentheses. So the first polynomial is fine. The second polynomial is fine because you have a plus, so it's like you're distributing a plus 1. That's not going to change anything. But on the last one, I am subtracting it, so there will be a sign change on my third one right here, okay? So let's go ahead and write it all out. So let's see, 5x squared minus 7x minus 8. Let's see, plus 2x squared minus 3x plus 7. And I'm going to color code the ones where the signs change. And so here this will become a minus x squared, a plus 4x, and then a plus 3. Okay, so depending on your comfort level, you could combine all your x squares at once if you want to. If you're like, okay, 5 plus 2 minus 1. If you're comfortable with that, great. If you're comfortable with that, go for it. If not, you can break it up into smaller steps and just do, just focus on this part real quick. And that's what I'll do just to make sure. I don't want anybody to get confused. But if you wanted to, you could combine all 3 like terms at the same time. But I'll do 2 at a time. So 5x squared plus 2x squared, that'd be 7x squared. Then let's see, we have a minus 7x and a minus 3x, so they're on the same team, so that becomes a minus 10x. And then the last part, we have a minus 8 and a plus 7. So those are competing. So subtract the smaller from the larger, which is 1. But the larger number was negative, so that means my result is. So my result will be a minus 1 right there. So that's that first part that I have in parentheses right here. Now I'll bring over what I haven't finished yet, the third trinomial. So let's see, minus x squared plus 4x plus 3. Now I'm going to do it all over again. So let's see. So I've got 7x squared, and I'm taking away, there's an understood 1 right there. I'm taking off 1. So I had 7, take away 1, that will give me a 6x squared, right? And then, let's see, I have minus 10x plus 4x. They're competing. 10, take away the smaller number, that would give me a 6. The larger number was negative, so my result is negative, or a minus, right? Same thing, minus 6x, okay? And then, let's see, then the last part, we have a minus 1 and a plus 3. They're competing once again, so, oops, my pen. Let's see. There we go. 3 minus 1 is 2. The large number was positive, so our result will be positive. And so there we go. Okay? So this just gets us, to be honest, it gives us a lot more practice on adding and subtracting, and you really want to refrain from using a calculator. Calculators are a great tool, but really we want to get this fundamental stuff down where you don't have to think about it, you know. And to be honest, it takes practice, and if it's not something you've done recently, you just have to practice it some, okay? And I promise it'll make the rest of the semester a lot easier if we get these foundational things down without using a calculator, okay? So that will be the end of part 1. Part 2, we will get into multiplying.